Good evening and welcome to April's Azure Cloud Native user group session. Back for another awesome evening of Azure Cloud Native information. Tonight we're focusing on Dapper and delighted to welcome Hugo Barona, who will bring into the chat in just a minute. I'm just going to hand over to Richard now, who's going to say hello and talk through our code of conduct.
Hello, everyone. Thanks for watching tonight. The code of conduct, very important part of any user group. So today we ask everyone to be aware of others, be friendly and patient, be welcoming and respectful, be open to all questions and viewpoints, be understanding of differences, and be kind and considerate to others. And with that, let's get rid of this and bring in Hugo. Hey, Hugo.
Hello, everyone.
Hey, Hugo.
How are you doing?
Good, thank you. How are you?
All good, all good.
Right.
Tonight it's Champions League, so just counting down, finishing my presentation and then go to see a bit of the game.
Very cool. So I guess we'll let you take away. Everyone's here to see you and learn all about Dapper. So the floor is yours.
Thank you so much. I appreciate it. Okay. All right. Tell me if you can see my screen. I assume it's all good, right? Okay.
All good, Hugo.
All good? Yeah, thank you. So first of all, thank you so much, everyone. And thank you for your time to join us and being here with us. And of course, thank you to the Azure Cloud Native group for this opportunity for me to be here. I hope you enjoyed this session. And of course, the session of today is all about helping you understand how to build microservice and event-driven apps using Dapper, okay? In this session, I will try to make it as smooth as possible and not really focus on development and code, besides the fact that, of course, Dapper is a developer-focused programming model, but my intention is more to create awareness and give you some understanding on how this can be useful to you and your teams, independently if you are, of course, a developer looking for a new tool to build some apps, or an architect looking for the best technologies to use while designing and implementing cloud solutions, or even an IT ops to understand how to manage and maintain apps built using Dapper, okay? So a quick introduction of myself. I'm a cloud solutions architect with a background in software development. So pretty much most of my experience is related to design and implement solutions using Microsoft Stack technologies, of course, while leveraging open source technologies. I'm also a Pluralsight author. So on my free time, when I have time, I just produce some course to Pluralsight related to different technology, and also a public speaker and tech community contributor. Also, quickly on my free time, I try to always refresh my knowledge and learn new technologies by just using Microsoft Learn and doing the modules and the learning paths, and then, of course, doing the exams to get the certifications. So it's an easy way for you to also provide evidence of your knowledge related to Microsoft technologies. And also I'm an MCT and MVP on Azure Academy. So let's get started. And nowadays, as you know, more and more IT pros are asked to design and create Microsoft-based architectures and applications, of course, so they can break and move out from those big monolithic architectures into something more distributed and Microsoft-based architectures, okay? Composed, of course, of small pieces, all connected and performing specific tasks and responsibilities, thus enabling them to implement flexible, efficient, and of course, resilient and scalable applications. And most important, enabling them to focus on building those applications and abstracting them from the infrastructure hosting those applications. And as you may know, a lot of developers always like to have some kind of freedom to pick the language or framework that fits their needs and fits, most importantly, the requirements, right? So, but sometimes, of course, depending on the requirements we have for our applications, there are some challenges that we may face while considering microservice developments, including limited tools and runtimes to build our applications, also limited language support and feature sets, and of course the runtimes that target specific infrastructure platforms with limited portability. Okay, so Dapper, so the distributed application runtime, known also as Dapper, is an event-driven portable runtime that enables you to easily build resilient and scalable distributed applications as a microservice on cloud and edge, and overcome common challenge while implementing distributed applications such as recover states after failures, managing secrets, or discovering and calling securely other microservice. So using Dapper, you can easily build microservice applications using any language, any framework, and run them anywhere. So you can see how strong it is, this paragraph, because pretty much it gives you a lot of flexibility. And one important detail is, of course, is that Dapper is an open source project started by, of course, Microsoft, and it is open to contributions of all of us. So in case you want to follow the latest updates and contribute to this project, follow the link to the official GitHub repository so you can have a look as well. And in case you are not aware of that, also in November last year, Dapper became a Cloud Native Computing Foundation incubating project. So there are huge efforts and investments in Dapper to make it successful and a popular tool. So moving forward to just talk about some of the goals. So there are many goals and advantage that Dapper is focused on. I will share some of them with you. And we start by talking about the best practices, followed to provide the building blocks to enable us to easily build and run our applications using Dapper. Also, it is designed to support any language or framework of your choice. And it also provides us a consistent, portable set of open APIs that enable our applications to interact with Dapper. Okay, and also, Dapper is adopting standards to ensure consistency across all the features and functionality that it provides to you and to your applications. And of course, we can leverage the extensive set of extensible and pluggable components to easily build additional functionality in our applications. And another important feature is the fact that it is platform agnostic. So that means that we can run Dapper and our applications in the cloud or edge, and pretty much you don't need to worry so much about requirements in terms of the infrastructure hosting your applications. And the final one, of course, and still important, it is a community-driven project, so vendor neutral. So it is accessible to everyone. Okay, so not necessarily you only are limited to run Dapper on premise or even on Azure, but you can run it everywhere. Okay, so now let's talk about one concept in Dapper, which is the building blocks. So a building block, it's pretty much just an API which is accessible using HTTP protocol or gRPC framework that is composed by one or more Dapper components. And the main goal is to provide capabilities to your applications. So you don't need to be building those capabilities, especially when it comes to integrations to external service and so on. So at the moment, Dapper provides you several building blocks, including blocks to enable you to perform secure service-to-service communications, also building blocks for state management, to enable you to implement stateless and stateful applications, blocks to implement PubSub or publish and subscribe applications, blocks to use the actors pattern in case you have the requirements to use this kind of pattern, or even blocks to provide observability of your microservice and much more. Okay, and in case, the most important thing is, in case you realize that you have specific needs and that none of those blocks and components available help meet your needs, then you can build your own building block and component and use it. That's the big part. So there is this extensibility available for you. And of course, you can always commit it to the official Dapper's GitHub repo, so other community members can use your code and your contribution as well. So as I mentioned previously, a building block is a set of one or more components, providing a specific capability to your applications. So a component really means a modular piece of functionality that provides an interface definition, and due to its pluggable nature, you can easily replace components in the building blocks and in your applications. So you will see during the demo how easy it is for you to create a component with the same interface and replace it with an existing component being used by your application and without any code changes required. So Dapper, one sec. So Dapper provides you an extensive set of components out of the box, as I mentioned before, and including state store components that represent data stores, including, as an example, database, files, and memory to store your application's data. Okay. Then also you have components for service discovery to enable the service-to-service discovery and simplify communications between the microservice. And of course, in case you need to build custom logic into the request processing pipeline, you can leverage the middleware components available, so you can perform actions such as authentication, encryption, or even message transformation before the request is routed to your application or before the response is returned to the user. Okay. Also, you have several components available to help you build your applications using the PubSub pattern. So these components will manage the delivery and the reception of all the message created by your applications and service. Okay. And a big advantage of using Dapper is the fact that provides bindings to several external resources, including Azure Storage, Cosmos DB, Event Grids, Event Hub, Service Bus, SignalR, and much more. Okay, so all these bindings enables you to provide productivity, to improve productivity by enabling you to easily connect your application with these external resource without requiring you to invest time on developing these implementations. So as an example, if you are familiar with Azure Functions, you understand how important it is, this story about the bindings available out of the box, which speeds up the development of your applications and accelerates the development and simplifies things, because definitely you can leverage the components available that are well tested, and you don't need to spend time developing, testing those components and make those available to your applications. And of course, to ensure that you're building and using secure applications, any private information, including connection strings and keys, you need to store them in secret stores instead of course, storing them in your application's configuration, which is commonly, in the past it was commonly used, or even storing them in the codes as hard-coded secrets, which is not a good practice at all. So you can leverage these components available to manage secret stores and manage your private information as secrets in those stores. So talking about now Dapper service, okay, the Dapper uses a set of service to support the runtime and the provided features. And of course, we start with the Dapper sidecar service. So Dapper uses a sidecar pattern, meaning that the Dapper APIs are run and exposed on separate process, in this case, the sidecar process. And this process runs alongside your application, providing additional functionality to your application. So sidecars are a supporting process that are deployed with your application, providing an easy way to leverage Dapper's features and components to improve your application's functionality, okay? And in those scenarios that you are running Dapper in Kubernetes modes, which is a mode that you can run Dapper, you will have a pod running the Dapper operator service, and this service will manage updates to Dapper components and also provides Kubernetes service endpoints for Dapper as well. And in scenarios that, of course, you are using as an example the actor pattern with your applications, Dapper use the placement service to calculate and distribute distributed hash tables for the location of Dapper actors. So this hash table maps actor IDs to pods or process, so your application can communicate with the actors. So anytime your application activates a Dapper actor, the placement updates those hash tables with the latest actor locations, okay? So, and of course, your applications running on Dapper need to be secure, right? So the Dapper Sentry service manage mutual TLS, also known as MTLS, between service and acts as a certificate authority. So it generates MTLS certificates and distributes them to any running sidecars. This allows sidecars to communicate with encrypted MTLS traffic, okay? So in case you are not familiar, MTLS applies a two-way authentication when establishing the communication between client and server. So that means that the client authenticates to the server and the server authenticates to the client as well, okay? That's why it's mutual TLS. And of course, when you're running Dapper in Kubernetes modes, a pod is created running the Dapper sidecar injector service, which looks for pods initialized with Dapper annotations, and then creates another container in that pod for the sidecar service, okay? So besides the fact that I'm talking here a bit about Kubernetes, one important fact is once you start to adopt Dapper, there are a lot of things. If you are familiar with running apps on Kubernetes, there are a lot of things that you will get abstracted from it, because Dapper itself manage some of those things that you don't need to really worry or manage by yourself, okay? Including the service discovery as an example, or secure service communications, and many more. So now I will provide you just a few examples on how to use the building blocks that Dapper provides to us. We have this example of service invocation, where I have my app running and preparing to call service A. So it starts by executing a post request to service A and methods, in this case, the method new order, and sending a JSON payload in the body containing a hello world message, okay? Just a simple message. This post request is using the service invocation API available in Dapper, okay? And then, of course, by doing this, our app puts the burden of service discovery on Dapper runtime. So the API will use the multicast DNS components for service discovery, so it can get the address of the service A before it calls it, okay? Then, of course, mutual TLS authentication is performed to ensure a secured connection between the APIs of the Dapper instance, running as sidecars and associated to the app and the service. Okay. After the successful established authentication, the request is forwarded, of course, to the service API. Okay. Then the API, of course, forwards the request to the service so it can process the new order. And once the request is processed, the response is returned all the way back until reach our app. Okay, so besides going into detail of each step in this diagram, most of these tasks are abstracted from the applications and the people using the Dapper. So because Dapper manage the service discovery and establishing the secure communications for you. Okay, I'm just giving you the details so you can understand how things work behind the scenes. So now another example. So in this example, it's an example of a state management call. And in this case, our app wants to persist some data into the data store. In this case, it's using Redis cache as a data store. Okay. So it pretty much just makes a request to the state API by providing the name of the DB. In this case, it's the core DB, and providing a body with all key value pairs that we want to persist into the data store. Okay, and then of course the Dapper instance gets the requests and performs the operation to store the key value pair into Redis cache instance being used. Okay, so this is another example, simple example on your app needs to pretty much persist data into your data store that you are using. In this example, you are using Redis cache, but it could be the same as using an Azure SQL DB or any other data store. Okay. And now we have an example like the demo I will show you today using the publish and subscribe building block. Okay. So all the publishing and subscribing is using Redis cache in this scenario. And again, our app makes a post request to the publish endpoint, providing the name of the pub sub components. In this scenario, it is orders, and the name of the topic, in this case, processed. Okay, and it contains a hello world message in the body. Then the request is processed by the Dapper API, which then executes the operation to send the message to the topic configured in Redis cache. Okay, and then of course Redis cache notifies the Dapper APIs subscribing to that given topic. Those APIs then call the service A and service B, providing the details of the message. Don't worry so much about if it's it looks a bit complicated. It's not really, in my opinion, but on the demo, I will show you just right now some details about how this scenario can be configured and used, of course. So, and talking about demo, here we go. And I wonder, Carl, Richard, do we have any questions so far?
We have one that's just appeared in the chat there about from Ravi about does Dapper support IPv6?
That's a good question, actually. Not really sure, but I would say yes, it supports IPv6 as well. So yeah, it should be fine. I would say so. But I would say that's something that you can quickly just, on the documentation, I will share with you, but definitely they are providing a lot of documentation. One important detail is definitely, as far as I know, Dapper is currently still in preview. Okay, so but definitely, especially Microsoft and the community, they are putting a lot of efforts into improving a lot Dapper. So if you access their GitHub repo, you will see a lot of commits and a lot of contributions constantly.
Perfect.
So yeah, let me just then bring the browser so we can start with the demo. Okay, and let me just do one thing here. All right. So first thing that is it clear, Carl? Can you just confirm, or do I need to zoom in a bit more?
Probably wouldn't hurt to zoom in a little more, but it reads fine for me. Yep.
All right, all good. So just to let you know, entry point for Dapper, if you want to follow and learn more about Dapper, definitely dapper.io, okay? That's your entry points. And in here, you have a lot of documentation, you have blog, you have the access to GitHub, where you can access the different repositories related to Dapper, okay? And the demo of today, it's based actually on a tutorial available in this site as well, okay? I just extended the demo to give you a bit more a complete demo to show you a few things about that. Okay, so if you go to the docs option in the menu, you have a lot of information about getting started installing Dapper. It's pretty simple. Just an FYI, currently I'm running Dapper locally using Docker desktop, and that's pretty much it. Then you just need to install the CLI, and then you need Dapper to just pull all the libraries to run the Dapper locally. Okay, and then of course you have the quick starts that you can have a look and give it a try, and also the tutorials. Okay, so on the tutorials, as I mentioned, you have a list that is growing every day in terms of tutorials how to use Dapper locally using the Kubernetes, and then different types of applications that you can build with Dapper. The one for today is focused on PubSub, okay? So on the PubSub tutorial, I just want to share with you first the diagram. So what do we have here? So what we have here is an architecture diagram composed by 3 applications, okay? So we have a React form, which is pretty much a web app built on React to just enable you to send message to subscribers. And then you have here 2 applications built in different language, as you can see here in Node and Python, and which are subscribing to specific topics to receive those message from React, okay? So it's pretty much just a simple example of you have a web app, and then you have 2 background applications which are subscribing to the topics and processing those messages. I will just one sec, I think, okay, it's fine. I was just wondering if the light is enough because it's getting dark here. All right, let's continue, okay? So yeah, for this demo, what I have, as you can see here, the PubSub is managed by using Redis Cache, okay? So we are going to start our demo by using the out-of-the-box tutorial that you have here. So you can give it a try by yourself to try it, run it locally. But then I will show you how simple it is to actually replace this Redis cache with a service bus components to use service bus topics instead of Redis cache. Okay, so let's start by jumping in quickly to the application. So as you can see, this has a GitHub repo, so you can clone it and pretty much just download it locally, and you should be able to just run your IDE, your favorite one. I use VS Code to just run these locally. Okay. I don't want to go in deep about development details because I want to make these as accessible as possible, but I just want to explain you a few things. So as you can see here on the PubSub tutorial, you have the Node subscriber, the Python subscriber, and the React form, okay? On each application, you have, of course, an API, okay, which provides different endpoints, okay, following the conventions of Dapper, okay? So it provides this endpoint for the subscribe, which returns a JSON identifying what are the topics subscribing. So this is the Nodes app saying, okay, I subscribe to the topic A and topic B, okay? Then you have the Python subscriber, okay, which has pretty much the same thing, okay? Subscribe, which provides a definition, returns a definition on the topics that it subscribes. In this case, the topic A and topic C, okay? One thing that I forgot to mention on the node is, for each topic that you are subscribing, of course, you need to have an endpoint which will be called when you send a message to that topic, okay? So if I send a message to A, then it means that the sender will send the message to the component, in this case, Redis cache or service bus, and then that component will call this endpoint A to just process the message, okay? And of course, Python, as you can see, the same thing. You have endpoint for A, endpoint for C. So that means Node is subscribing to topics A and B, and Python A and C, okay? And then, of course, you have a React form, okay, which contains a client with all the DLLs, well, sorry, all the source code for rendering the pages. And then you have a server, right, which pretty much as a publish endpoint, okay, which means that the client is calling these endpoints. So when we click the button, the client, I will show you in detail in a sec all of this, but the client will call these endpoints, publish, in order to send the message to the subscribers, okay? And this endpoint, what is doing is, of course, calling the Dapper API, the publish API that I mentioned before in the sites, and providing the details about the pub sub name being used, and of course the payload, okay, for the message. So let's start by running this locally, okay? So I'm just going here to transfer to Windows Terminal, okay? So what I have here is, I have a Node subscriber, okay? If you follow the tutorial, you will see all the commands on how to run these, okay? So pretty much it gives you all the commands on how to run the different applications. As you can see, we start by having in order to run the Node subscriber, we need to navigate, of course, to the folder of the Node subscriber, run a simple npm install to install all the package, and then you run this DAPR run command, okay? This DAPR run command, it's a simple command that just provides an app ID. So each app that you run on Dapper, you need to provide it an ID, which provides as well the port that you want to run, and then the command that you want to run. In this case, it's node app.js, because this is the source code file that you want to run for that. So we start by running these commands, and you will see that you will have details about, okay, it's up and running, okay, it's all good. Now we need to flip back to the Python subscriber, and once again, as I told you, you go to the Python subscriber, no big deal, navigate to the Python folder, then you just run the command to install the package, okay, which are mapped on the requirements.txt file, and then you just run the command again to run Dapper, okay, which you are providing once again an app ID and a port, and then the command to run this application. So I'm going to copy this command here, and I'm going to just run. The only difference is I don't have Python 3, so I just remove the 3, and it should be fine to run it as well, okay? So it's all up and running, okay? So now we need to, of course, run our React frontend, which will enable us to submit the message, okay? So once again, navigate to React folder, then run a task build client for npm to just build the client, and then install the package, and then run the Dapper command, okay, to run the app. And once again, I'm going to navigate to the tab of React form and just run the commands. All right, so it says us, okay, it's listening on the port 8080, okay? So what I'm gonna do is I'm going to just navigate back to and I'm going to open here port localhost 8080, okay? And we can instantly see here the example running, okay? Which in this case, it's the React app front end that is rendering here, okay? One thing I want to show you is I'm going to just open the inspect, I'm going to network, and I'm going to, as you can see, you have a drop down that it enables you to select the topics, okay? In this case, we are going to select first the topic A and send a message to both applications, to Python and Node, because both of them are subscribing to that topic. I'm just going to clear here the network. I'm going to just write hello Node and Python, and just say submit. When you click this button, it will call that endpoint that I told you to pretty much just publish the message. Okay, so as you can see here in the network, it's called endpoint publish. Okay, and it's 200. Okay, all good. So if I go back to my application on React, you see here the logs about saying publishing the message. Okay, hello Node and Python. Of course, on Nodes, you can see here that received the message, hello Node and Python. And in Python, as you can see here as well, it received the message on topic A, okay? So this is just a simple example. I'm showing you how you can just start with these examples, okay? Now let's imagine that I just want to send a message to, I'm just closing here this to simplify. I just want to send a message to Node, okay? Hello Nodes. So I just hit submit, and once again, I go back to Python. I don't see anything on Python, as you can see, no message, because Python is not subscribing the topic B, but I see here on Nodes, hello Nodes, and also I see on React confirming that it published the message. And the same, of course, applies to Python, okay? So Python is subscribing to topic C. I just can say hello Python and just submit, send the message, and once again hello Python, and this is the React. I can see here on the Python app that received the message, and also I can see that Node did not manifest because there is no it's not subscribing the topic B, so consequently did not log anything. Okay, so now the question is, okay, we have, going back to our architecture, okay? Let me just, in the meantime, just 1 sec to turn on the light here because it's getting really dark. Okay, fair enough. So yeah, so now what we want is, okay, let's see how easy it is, because this is definitely one of the advantage of using Dapper. Let's see how easy it is to replace Redis with Service Bus, okay? So of course, go to the Azure portal. I have here a few resources that I want to show you later in this demo, but this one, Service Bus namespace. So I created a Service Bus namespace before, and pretty much, as you can see, there are no topics at the moment, okay? So what I'm going to do is, of course, first configure the components, and then secondly, configure the topics here. So then we can run Dapper once again and start to use Service Bus. Okay. So what I'm going to do is, going back to here, I'm going to actually open a new tab, just to show you the process that you can do when building the components. You can go to the docs, then you should have here an option to reference, and you should have here component specs, and then you should have here pub/sub components, and in here for the pub/sub brokers, as you can see, you have a list of all the supported components, okay? And of course, Microsoft Azure, you can see you have support for Event Hubs and Azure Service Bus, okay? So what I'm going to do is pretty much just open this. Then I just see here the spec of the components. This is the spec that I'm going to use. So just to show you quickly in here. So once you init and install Dapper locally, you have a folder dedicated for the components. As you can see here, we have the state store and the pub/sub. At the moment, I can actually show you. So we have the state store using Redis, and we have the pub/sub, which we are using Redis as well. Okay. So what I'm going to do is, I'm going to first start by copying this spec. Then I'm going to here, and I'm going to create a new component, call it servicebus.yaml. Okay. Then I just paste here this. Of course, we need to change one thing. As you can see, this is the connection string, which is required for the authentication. So what I'm going to do is I'm going back to the portal. I'm going to my service bus namespace, and I'm going to shared access policies. When you create your service bus namespace, you have by default a policy. Just by the way, this is not the focus on explaining you this kind of service bus, but just to give you an introduction in case you're not familiar with service bus. This is an enterprise messaging service available on Azure, okay, which allows you to use queues and topics to just build those messaging and event-driven applications. Okay, so I'm going to just open this policy, and I'm going to copy the connection string. Okay, so going back to the component spec, I'm going to just replace the query string, okay, the connection string here. And once you save it, it's all good to go. Now I'm going to just minimize this. I'm going back to, actually, no, one sec. So one important detail is each component is identified by a name, okay? So this is really important. And this is the way that I'm going to use to say to my app, to my example, demo app, to say to use these components and do not use the Redis component for the pub sub, okay? So this as a name, so I'm going back to first Windows terminal. I'm going to just stop everything and clear, so it makes it clear, okay? So once again, I'm going to the source code of these applications. One important note is I'm going to change the source code, but doesn't mean you need to change the source code, okay? What happens at the moment is these tutorials have all the configuration hard-coded, okay? Of course, in a production app, you would store those configurations externally outside of your source code. So that means you wouldn't need to even touch the application, okay? But for the purpose of this demo, I'm going to the Node app first. And in here, you will see that the subscribe is specifying the pub sub name. And this is the one that I'm going to change, okay? I'm just going to say, instead of using the pub sub, which is using Redis cache, I want you to use the service bus pub sub, okay? Which is the new component that I created. And I just close this. Now, I'm going to the Python subscriber. And once again, the same thing. On the subscribe endpoint, I'm going to change the pub sub name to use the new components. And on the React form, of course, the server, remember the server as a publish endpoint, which sends the events to this publish API. So we need to change the pub sub name here as well, okay? So all good. Now I should be able to just go to, one thing, sorry, quick one. We just forgot, we cannot forget, of course, about creating the topic. By default, Dapper is able to configure and create the topics, but yeah, sometimes there are some odd things that happen. So I'm going to create the topics at least, okay? So we know that we have topic A, B, and C. The subscriptions, so each one of these topics are managing subscriptions, okay? So you can have apps subscribing to each of these topics. The subscriptions you don't need to care about because the subscriptions will be set up by Dapper by itself, okay? So I'm going back to Windows Terminal and I'm going to just run the application. So I run Node application. I run Python. Okay, all run, all good, and I need to run, of course, the React. I just need to do one thing, which is, well, actually it's optional, but I'm going to do it anyway. So just to run the npm run build client, okay? So I'm just going to run the build client to just rebuild the clients. So these steps I'm doing, running npm installs and so on, they are not really relevant to the purpose of using Dapper, because you, as I mentioned before, you can use Dapper with any technology and any stack that you want. Okay, so I just rebuild the client, and now I'm going to just run this again, and hopefully. So this is running. Now let's go back to our browser. Let's just refresh once again. I'm just reopening the developer tools, going to network to be sure that this is sending properly the message. And I'm going to topic A once again. This time, hello, Python and nodes using service bus, okay? I'm just going to copy this and cleaning the networking and submit. And as you can see here, publish 200. So it's all good to go. Okay, so let's go back to our terminal. So as you can see here, we have the message sent on the React as a confirmation. On the node, we have the message received, okay, and printed. And on Python, of course, we have the message received as well, okay, here. All right, and to quickly show you, if I go back here to my service bus namespace, if I refresh, see here, now I have my subscription count 2, 1, and 1. So if you navigate to any topic, you will see straight that you have the subscribers here, Node subscriber and Python subscriber, okay? So this is just a simple example, okay? But the most important, the key takeaway here is to show you how simple it is to just replace components in your application, you know, using this programming model, okay? Because it's pretty much, as I said before, if you are familiar with Azure Functions, you will know how easy it is most of times to just spin up applications there and avoid implementing integrations when you are using Azure SQL database or Azure or Cosmos DB or even service bus storage accounts and so on, you know. So that's the beauty of this. This is a really powerful feature in Dapper. So now I want to move to the second part of the demo. And before I move, any questions so far, Carl?
Yeah, actually there are. Ravi has asked a couple of really good questions, so I'm gonna. This one has been. This one has already been answered to a certain extent within the chat, but I'm going to post it for you anyway. Can you see that?
Not really, Ravi. See, actors is only a pattern that you can use with Dapper, okay? Of course, you can use, for example, as you can see here, I'm using completely a different pattern, which is the pub sub, you know, pattern, which are not in any way related to the actor pattern, you know. So the actor pattern is only one way that you can use Dapper, essentially.
Okay. I'm just going to post the response from Adam White just for context. Thank you, Adam, for responding in the chat. That's great.
Yeah. Okay.
Yeah.
And definitely agree with Adam. Thank you, Adam.
Another great question before we let you get on with the demo is this one: does changing components require app downtime?
That's a good question, actually. Okay, so as I mentioned before in the slides, Dapper is able to pick up the components changes that you do. Okay, but one important detail is, of course, imagine since I changed my application to use one app instead of other. Okay, that means it may cause downtime. Okay, it all depends on the way you are managing those configurations. Okay, so as an example, just loading here Visual Studio Code again, 1 sec, just to quickly explain you what I mean. So imagine you have this node app, right? And you have here hard-coded the name of the component to use this, all right? But imagine that you have this mapped outside externally, okay? Imagine that you have in a table storage or whatever. And in worst case scenario, you would do a query to the table storage, get the configuration, load in your application, use it, and maybe use local cache to just avoid constantly being querying table storage. but that means you would possibly you could go to table storage, which is mapping and managing the configuration externally, modify the configuration there, and then just somehow refresh expire your cache, to just force the application to just on the next request to reload the configuration. Okay. That could be a way, or you could just fire a restart on your application, and it would be minimal downtime, if you know what I mean. There is always, that with microservice there is always ways for you to even modify your applications and avoid downtime by using partial updates. So you can update one application, just restart it while you have another instance running, and then just do the opposite, and that's it. And you can reflect those changes without impacting fully the application, I would say. Yeah.
Perfect. I'll remove myself again and you can carry on. Thank you.
All right, thank you. And let's try the last piece. I think it's really interesting piece in my opinion. And but I want to just highlight, okay, this is using the word is not coming to me at the moment. Anyway, this is not in GA at the moment. It's preview. Okay, preview mode. That's the word. So I'm going now to show you how you can actually run Dapper with Azure Container Apps. Okay, which is an hot topic at the moment, and which I believe it will be a really interesting topic for you to explore as well. On my reference in my sites, I will share with you as well a tutorial if you want to use it, the tutorial to see how you can easily use HCA or container apps with Dapper. Okay, so let's just do one thing. Let me just look here to my notes. Okay, all right, so see, we have our applications here, right? First, I should maybe start by showing you what I have here, okay? So I'm going to just close all of this, maybe just to be sure that we are going in a clean mode. Let me just quickly delete the topics, okay? So we don't have any confusion here. So I just want to delete the topics in order to delete the subscriptions that was created, okay? Because this second part of the demo will create new subscriptions, okay? Because we are going to spin new applications in Dapper. So let me just delete the topic B as well and delete the topic C. All right, so we should be clear now. Okay, all good. So I'm just going to quickly recreate the topics, empty topics without any subscriptions. So topic A, topic B, and topic C. Okay. I did not, to be fair with you, to be honest with you, I did not have enough time to test this, so I hope it works. But if it doesn't work, I just kindly ask you to be patient with me. So I have the topics A, B, and C. Okay, it's clear, as you can see, no subscription at the moment. Okay, so what do I have here on the my resource group? Okay, so I created a container registry. Okay. Because see, we are going to use container apps, so that means you need to create containers for your apps, and then of course you need to have a repository to store your containers. So then when you are going to create your container apps, you are going to provide details of the location of the repository to use the given image that you want to use to create your container. Okay, so at the moment I have here in essence of time, I have here already configured two repositories for my Node app and my Python app. Okay, now I need to create, of course, the repository for React app. I'm going to show you the steps, but pretty much Node and Python follows exactly the same steps. Okay, and all right, this is the repository. Now, of course, I have an environment. I want to share this with you before I start because this is really important as well. So I have an environment, all right, which at the moment has no apps. As you can see, it's clear, okay? But one important detail is when I created these environments, okay, remember, we are going to create exactly the same architecture here using container app. So I'm going to create a container app for React form. I'm going to create a container app for Node subscriber and a container app for Python subscriber, okay? And I'm going to connect all of them using service bus, okay? So that means the component that I had to create and configure it locally, you need to do exactly the same thing in your environment, in your container app environment, okay? So I had to use, in this case, I just used Azure CLI and just ran a few commands to just create the app, okay? On the tutorial that I'm going to share the link with you, you will see all the details on how you can create components and configure in your environment, okay? So yeah, let's proceed. So I'm going to back to my, I'm just going to stop here this to just avoid any confusion. And I'm going here to VS Code, opening the terminal, and all right, as I said, I want to do all the process for the React form, right? So I'm going to start by navigating to the React form. One important detail is this tutorial. If you try by yourself, this tutorial comes for each app with the Docker file, okay? This Docker file enables you to create your image, Docker image for your application, okay? As you can see here, you have all the commands to use the environment, the work dir, the copy, commands to run, and so on, okay? So what I'm going to do is I'm going to use this Docker file in order to build my image, and then I'm going to tag the image and then push to my external repository, okay? So first thing we need to start is with the Docker build command, okay? And then you just specify a tag. In this case, I'm just calling it Dapper demo React, and then the version, which is v1, and a dot for the local directory where the Docker file is located, okay? So let me just close this so we can see all the details here. All right, so I have my image built. Now I need to tag the image in order to be able to push it to my container registry repository. So what I'm going to do is Docker tag commands, then my tag, my local tag of my local image, and then the external tag for the external image that I want to push. Okay, so I'm just creating again this tag. And one important detail, of course, you are using ACR, okay? So Azure Container Registry. So before you push, you need to, of course, log in, okay? So what I'm going to do is AZ for the Azure CLI, and then ACR, and then log in, and then the name of the registry, okay? You just log in, hopefully it will work. One important detail is be sure, I'm not going to load this because I don't want to provide details of the account, but be sure that you are using the correct account, okay? So if you run AZ account show, it will show the details of your account that you are using. And then if you want to set the correct account, you can use AZ set account set. I think that's the thing. And then you just specify the subscription and you put the subscription ID, okay? This is just a way to interact anyway with this, okay? You can interact in other ways, including have ARM templates or bicep templates and do all this process. So I just logged in. Now I need to push my image, okay? So I'm going to just run the Docker command push, and then I just specify the domain of the registry and then the tag of the image, okay, that I want to push, okay? So as you can see here, it's going to push the image, right? And then the next step is, okay, I have my registry with all the image that I want to use. Now I have my environment, my Azure Container App environment. Now I need to run commands to create my container apps. Okay, one way that you can do this is by using once again the Azure CLI. So what I'm going to do is I just want to show you here the command that I'm going to run, cls. So what I have here is az, right, CLI, container app, domain, create, action, and then name of the app, resource group, environment, the name of your environment that you have available. Sorry, then the image that you want to use. In this case, it's the image that I have there available in my repository. Then the registry server, the username, and the password, okay, of your registry. And then optional, you can configure min replicas and max replicas for replication of instance. And most importantly is the flag to enable Dapper. Okay, I'm just going to maybe just appearance, zoom in a bit more. Yeah, then enable Dapper flag, okay, which is really important. So you can enable Dapper on your container app. And of course, that you need to specify once again the port and the ID of the app that you want to run, okay, as we did in running it locally. Okay, so we just run the commands. Let's hope this works. So this command is pretty much doing what? It's creating our container app to host our Python subscriber, okay? Okay, it's all good. So now what I'm going to do is I'm going to run my command for the nodes. Okay, so I have my Python app running there. Node is pretty much the same thing. You just need to change the name of the app, the image, and pretty much all the rest, and of course the Dapper parameters, port, and ID. Okay, so then you just run the command, create app. So as you can see, also the AZ container app is in preview and under development. So if I would say if you give it a try, if something is not working as you would expect, just access the GitHub repository and just open an issue there, you know, for the Azure CLI in this case, of course. And the third one, last but not least, my React app. Okay, so once again, same commands. The big difference here is, okay, as you can see here, ingress. So you are activating ingress in order to enable to be accessible externally. Okay, so that's the main difference here. Pretty much all the rest, it's all about just changing names and image, and that's it. So once again, just run the commands. Okay, all good. So we have our 3 apps done. Okay, I know that we are a bit over. I just need 5 more minutes if it's fine to you, and I close the demo. And I just want to definitely give you this additional detail about how to use container apps. So quickly, RG, if I go to my resource group, I just refresh. Now you can see I have here my applications, container apps created. Okay, you can open any of those. I'm going to open the React because we need to access the Reacts. Okay, and one important detail that I'm going to show you here as well is one way to track remember, we are running 2 background apps, which is the Python and the Node app. So one quick way that you can monitor those apps is by using the logs, okay, of the app. So in here, I should be able to just go here to the URL, and as you can see, it opens the same app, but in this case, using the URL of the container apps. I'm going to also inspect to ensure everything will run smooth. Going to the network. Before proceeding to run the test on this, I'm just going to do a query here. I just have here a query for accessing the console logs, and I'm just filtering to ensure that it shows the logs of the containers related to my apps. Okay, so in here, as you can see here, we have logs for the different applications. Let me just try to collapse this and maybe go a bit upper. Okay, so as you can see, maybe zoom in a bit. As you can see, we have logs for the different apps, okay, and which gives us, this is UTC time, so that's why it's showing 8 p.m. But pretty much it's showing the Node app running on port 3000, the Python app running, and also our React app running on port 8080. Okay, so if I go back to the React app, I'm just going to just say hello nodes and Python from ACI using ACI. Okay, ACI no. So if I clear the network, submits, and as you can see, publish 200. Okay, so it's all good theoretically. Okay, let's see now. If I run the logs again, I can see here that's definitely, see here, I have here a log from Node app, which just logged here the message, hello Node and Python using ACI. I also, this is the Node app. Then I also have the Python saying, okay, I received the message using hello Node and Python using ACI, okay? And also I have the React log saying, okay, I published this message, okay, that we just specified. And given that, we close the demo, and pretty much just to show you a quick and simple example on how to use Dapper. And of course, if you want to give it a try using ACI, that's the best of two worlds, if not. I mean, I don't know, Carl, do you have any questions? Richard?
You just add us both in at this stage. So thanks for that, Hugo. That's great. Question. So Ravi says thank you for answering his questions. And then I'll stick that up for comment.
Well, listen, if this Dapper is definitely designed for in scenarios that you have microservice and distributed applications. So if you have a monolithic in a VM, unless you have a lot of integrations with that monolithic, that scenario could use maybe Dapper. Okay, so you could put Dapper on top of your monolithic app and then manage all the integrations using Dapper. Okay, instead of changing your monolithic app all the time. So you can just provide an API on your monolithic app to just avoid minimal changes, and then put Dapper in the as a middleman, just doing all the connections. I would say so. That's the way I visualize it, to be honest.
And then move it over to microservices as soon as possible.
Yes, definitely.
Yeah.
Definitely.
Refactor, re-architect, quick.
Yeah. That was definitely an awesome session, Hugo. I really enjoyed it. One thing I did notice, your hoodie seems to say Cloud Lunch and Learn. Can you tell us a bit about that, please?
Nice segue into community stuff now.
Yes, so this is the clothes that we created for our Clouds Lunch and Learn Marathon we did last year. And just to give the example, of course, I just bought one of the hoodie and also a shirt as well. I have their store, and that's just trying to give some gifts to the community. We delivered some free Cloud Lunch and Learn clothes during the event, but of course there is a cost associated. We cannot give for everyone for free, unfortunately. I would love, but.
Do you want to tell the watchers or the viewers a bit about Cloud Lunch and Learn?
If you want,
what it does, what its purpose is. We've got a couple of minutes and then we'll wrap up, but might as well give you an opportunity to tell the community what you're doing in the community and what initiatives you're supporting and operating in. So.
Okay, so to give you a pretty quick the story about Cloud Lunch and Learn is simple. So I have been, as I told you, I have been software developer for a long time before even nowadays joining the journey of being an architect. And I always love the story about lunch and learn with my teams, on the different companies, because I think it's really a nice thing to do instead of at the end of the day when you are tired to just go home, or go to a meetup. It's fine, it's good meetup, but you know what I mean? You are tired already, lots of times you don't have motivation for it. So to summarize, when it came the beginning of the pandemic, all these lunch and learn stopped. I was running some sessions locally in Dublin, in a few meetups, and I just decided to give it a go with Cloud Lunch and Learn, and the name just states the purpose. So the idea is to just start with lunch and learn sessions, so we can enjoy some good food and learn about technology all together while we are doing our breaks. And then, of course, Cloud Lunch and Learn quickly expanded. We definitely decided that apart from the sessions, because especially if you are a guy that you want to test the stuff, attending a session and following these guides is it's not enough. Sometimes we want to, I talked by myself personally. We want to feel proud of ourselves about building significant things, things that make difference. So we decided to give it a go, try to create a concept of Ideathon. Pretty much Ideathon is not something new, completely new. You have already hackathons, but the problem of the hackathon is it's really focused on developers. Okay, so most of the time you spend developing stuff. So the Ideathon, we just decided to focus on the idea. So to enable everyone to go there and build their ideas, put your brains working, using technology. And then the third one is all about conference. So marathon, the first edition we did last year was 24 hours continuous running. It was great because we were able to reach a lot of communities. I met a lot of people, especially in Asia, in Africa, and China. It was great, man. It was great. I always like this connection part to meet people and share ideas and put our brains to work together. That's the beauty of these things, So yeah, so Cloud Lunch and Learn, as I used to say, we are always open. We collaborate with a lot of people. Carl and Richard at the moment are here, but they are collaborating with us as well. So we always welcome everyone, as long as you want to, of course, implement your ideas and create value to the community. That's our main purpose, And that's it. So we welcome everyone to attend our initiatives. And the same way as I always say, okay, I'm not elitist, okay, so don't attend. What I'm saying here is don't only attend Cloud Lunch and Learn. Attend all the community groups that you are interested. The most important thing we are doing here is it's all about delivering you ways to learn and improve yourself, get more opportunities, make things accessible to everyone. Okay, so remember, not everyone has a powerful computer to test these things online, and not everyone is accessible to books that can buy books or do certifications. So this is the way to just make things more accessible to everyone, independently where you are. And so that's essentially my message all the time. Please support all the community groups. Share I see communications from different community groups, and I see a lot of people that don't share. Please just share. It's 1 minute, okay? Promote, help those community groups, because they are working for you, okay? They are working to help you. So, but at the same time, we need your help, because ultimately what we are doing here, and I talk specifically from the Cloud Lunch and Learn side, is we are trying to bring the power from companies, because ultimately we have no power, okay? We have only our energy. So we are bringing the power and the money from companies, and we are trying to distribute a bit the power to the community, okay? So make things more accessible, delivering free vouchers, so to enable people that cannot afford to pay an exam to just get a free voucher and do the exam, okay? Get opportunities for people to win prizes, including vouchers. For example, on the marathon and on the Ideathon, we delivered Amazon vouchers. which enabled people to buy stuff, useful stuff. There were some people buying tablets to study and so on, or buy a new phone, whatever you think is useful to you. So yeah, but this all requires the support from community. Okay, you need to make noise. You need to go to the social networks and share, ping, whatever, do everything and support these groups. Okay, in general. Okay, not only Cloud Launcher Learn, of course.
That's
definitely.
fantastic. We like to support all of the community, not just Azure Cloud Native, but it's great that you've stopped by to see us tonight, and it's great to hear that you've stopped by to talk to us this evening. If you want to find out more about Cloud Launch and Learn, if you scroll further up in the chat, I have posted the YouTube link and the website link in the chat there, so you can click that and find out some more.
Thank you. And yeah, to summarize here, I hope you enjoyed the session. Feel, as I always say, I'm always open to connect with people. Feel free to reach out if you have any questions. I can help you. I can try to help you. Okay, I can help you. It's a strong word. I can try to help you as much as possible. To be honest, I'm not an expert on these things. I have been exploring. I know enough to just use Dapper and container apps, but to be honest, I'm not an expert. I don't consider myself an expert on these things. I'm just learning the same way as you. I hope I just express my knowledge in a way that help you to just get started soon and quick using these things. Yeah.
Awesome. Yeah, definitely. I've learned a lot this evening, so thanks for that. I'm going to go, and with my IT ops background, I can see how Dapper can help make my life easier for people. So I'm going to definitely go look a bit further into Dapper. And yeah, so cheers for that. And thanks for telling us all about Cloud Launch and Learn. It's definitely something everyone should try and get involved in and promote. And obviously, we've got your Twitter handle on the screen, so everyone can use that to reach out to you. And yeah, thank you very much, Hugo.
Thank you so much once again for the opportunity to be here and everyone attending this session. And I hope to be back soon. And in the meantime, feel free to contact us and contact me in case you have any questions or you need any help. Yeah.
Perfect. Right. Thanks everyone for attending and watching. We'll see you next time.
Yeah. See you next time. Champions League time. Bye bye.
Yeah, bye.